Hi everyone. Today we are moving on to talk about our next conic section, which is going to be the parabola. So you all are pretty familiar with what a parabola looks like, and you've talked about it all the way since probably Algebra 1. And we know that in general, y equals x squared is going to be our parabola opening up or down. And if we have x equals y squared, that would be our parabola opening sideways. The same basics are going to still hold true. The parabola is when we take one of our two cones that we've been talking about for our conics. Conic sections refer to slices of cones. And if we slice down at an angle like this gives us our parabola. So also a little homework for you all. In honor of our conic sections, it always makes me think of an ice cream cone or a snow cone. So take a drive and go out to Brewster's or someplace and treat yourself to an ice cream cone because you certainly deserve it. Definition of a parabola. A parabola is the set of all points, x, y, in a plane that are equal distance from a fixed line called the directrix and a fixed point called the focus. That is not a line, it's a point, not on the line. Okay, so you can see here we have two vocabulary words that we've never discussed before when talking about a parabola. When we're talking conic sections, we're always talking about the points x, y that make up the points on the parabola as being a set distance from something. So when we talk about the ellipse, the hyperbola, the circle, they'll all have some type of definitions that's talking about how the points are created. With a parabola, we talk about them being equal distance from two things. A line called the directrix. This is your directrix. This line back here, you can see that it's behind your parabola. And your focus, which is right here in front of your parabola. This I always remember and equate it to an old video game called Pac-Man. Hopefully you all have seen Pac-Man. And this reminds me of Pac-Man trying to eat the chips and maybe the ghost or whatever might be in its way. The directrix is always going to be behind. So for every point on this parabola, like for example, the vertex point, we know all parabolas have vertex points. The vertex is equal distance to the directrix and to the focus. Now, those distances change. They become longer from this point on. Like if we're talking about this point over here on the parabola, this distance and this distance is different. However, they are the same distances to the focus point in the directrix. This point over here, this distance and this distance is longer than the other two distances we just talked about, but they are the same distance to the focus point in the directrix. So that's what it's talking about in the definition. Okay, so our standard form of the parabola is going to look a little bit different as well. We talked about it a minute ago, x squared equals y. Actually, we usually write it as y equals x squared, getting y by itself. But now they're going to take everything that's squared to the left-hand side. And this is going to be y squared equals x form. So when we know x is squared, it's going to have a vertical axis of symmetry, and so it's going to open up or down. And when y is squared, it's going to have a horizontal axis of symmetry, and so it would open left or right. We've seen h and k before in some equations. hk is going to be the point that would be the vertex of the parabola. So that is how you will know your vertex, just by looking at the equation. Down here you see no hk, and that's because the vertex is at the origin. And then we have this number sitting out in front of the non-squared term, and this number is going to relate to a variable we call 4p, and p is what gives you that distance from the focus to the directrix through the vertex. So this distance over here, oh, my iPad froze on me. This is p. Let's see if it comes back. Anyway, yep, it came back. Okay, good. So this distance is p and this distance is p, and that's going to help us to graph our parabolas. Okay, so this just goes through the shape. If p is positive, it opens up. If x is squared and p is negative, it opens down. If y is squared and p is positive, it opens to the right. And if y is squared and p is negative, it opens to the left. And then we also have another new term called the focal chord. And this is a line segment that passes through the focus to 2 points on the parabola. And I'll describe to you what the focal chord does for us when we actually graph a couple. So here's my first example, and they want us to find the vertex, the focus, and the directrix of this parabola. And since y is squared, we should know that this is going to open to the left or to the right. And since our 4p number, that number is right in front of our non-squared variable, this equals 4p. Since 4p is negative, that means we're going to go in the negative direction from the vertex to get our focus point. So if we go in the negative direction, this thing would open to the left. So because there's no HK, we know that our vertex is at the origin, 0, 0. We already said that 4p is equal to -6. So if I divide by 4 and I solve for p, we know that p equals -3/2. So that means you're going to go -3/2 in this direction to get to your focus point. So that's -3/2, comma 0. And you would go equal distance behind it to get to your directrix point. So you're going to go 3/2 in this direction. And you're going to draw a line behind your vertex. And so that's a vertical line. So we know vertical lines start with x equals. And so x equals, oops, that's not negative. That's +3/2 because we're in the positive direction. And now it's time to talk about that focal chord. The focal chord is always 2 times p. Well, our p value here is 3/2. So if we double that, we get 3 or -3. It's a distance, so we just need to think about 3. You are going to go 3 units out from the focus in either direction. So we're going to go 1, 2, 3, 1, 2, 3. And that gives you 2 more points on the parabola. So that helps you to graph the shape and to give it the right shape, whether it be wide or skinny or whatever. So your focal chord distance is really equal to 2p, which would be 2 times 3 or 6. And that's 6 units right there. Next example. Okay, this one, they kind of wrote it in a little bit of a different form, just so you understand that you're going to want to keep your squared term over on the left-hand side, and your non-squared stuff is going to be on the right-hand side. So a little bit different than what we're used to talking about. Since x is squared, we know that this one's going to open up or down. And our 4p value, kind of jumping ahead, is -8. So I'm going to say this one's going to open down. My vertex is HK. H always goes with X. K always goes with Y. And we're always going to go with the opposite sign. So our vertex is at 1, -2. So if you graph a point at 1, -2, we are on our way for this example. 4p is equal to -8. So p, change my color here, p is equal to -2. So this is going to open up or down. We're going to go 2 units this way, and that's going to give me my focus point. So we went 2 more units down, so the x stays the same. Our y is going to be -4. And we're going to go 2 units back for our directrix. So our directrix this time is a horizontal line. Horizontal lines start with y, and that would be y equals 0. And then to give us a little bit of an idea of how wide this parabola is, remember we take 2 times our focal chord, or 2 times p, to get our distance, which would be our focal chord, which is 4. So we're going to go out 4, 1, 2, 3, 4, and out 4, 1, 2, 3, 4. And oops, I forgot. I'm sorry, I did that. You should do it from your focus. So let's go back and erase those points. We don't want these. These are points on your parabola, so you don't want them to line up with your vertex. And that will give you your distance to give you some shape for your parabola. Okay, next one. They wrote this in a slightly different form. You can see that it doesn't have our nice HK. So at the beginning of the year, we did this. We worked with this. We did completing the square to get it in our nice standard form with HK that we liked. So guess what? We're going to do the same thing here. I see this one. You might want to get the squared term on the left-hand side first. Also, when we complete the square, remember we always want whatever's in front of the squared term to be a +1. So I am just going to multiply everything through here by 2, and I'm going to switch sides for everything. So if I multiply everything through by 2, I get 2y equals negative x squared minus 2x plus 1. But now I'm going to swap sides. So I'm going to take this over here and this over here. And so I have x squared plus 2x minus 1 equals a negative 2y. So that's what we're starting with. Next, to complete the square, you want to take your constant to the other side. So now we have x squared plus 2x equals negative 2y plus 1. And now comes the completing the squared part. You take half of your middle term, which is going to be 1, and you're going to square it, and you're going to add that number to both sides. Remember, the whole point of completing the square is because this is special. This is a perfect square trinomial. This factors back to x plus 1 quantity squared, which is really nice. Over here, we're just going to clean this up. This is negative 2y plus 2. And then over here, we need a number sitting out in front of a quantity. So we're going to have to factor out our GCF. So if you factor out your GCF, the left-hand side stays the exact same. We have a negative 2 out in front and then y minus 2. So this is our standard form that we're now going to use to graph this. Oops, not y minus 2. I forgot to factor out the 2 there. That would be y minus 1. Okay, so now we look at it for these questions. HK still goes with x and y, so this is negative 1, 1. My 4p is equal to negative 2, so p equals negative 1/2. Let's see, x is squared, so at negative 1, 1, we have a point. That's going to be our vertex. And since x is squared, it's going to open up or down, and it's going to open down, and I'm going to go negative 1/2 in front of it. This is going to be a teeny tiny little parabola, and we're going to go 1/2 behind it. So kind of hard to draw all this. If you want to scale it by 2, you can. So my focus point is going to be negative 1, positive 1/2, and my directrix is a line. It's a horizontal line. So that's going to be y equals, and that would be 1.5 or 3/2. And then to get my focal chord, we are going to double p. So 2 times p, you double it, you get 1. So you're going out 1 unit here, 1 unit there, and there's your little teeny tiny parabola, like I said. Next, they will give you some equations, and you need to write the equation of the parabola. So here we have a problem where the parabola is going to be in standard form with the vertex at the origin. X equals negative 2 is the directrix. So that tells me that P equals 2. If the directrix is there, it's going to have to open this way. So that means P is going to be positive 2. It's opening sideways. So y is squared. So y squared equals 4p times x. P is 2, so y squared equals 8x. Next one. This time the vertex is at 3, 2. And our focus point is at 1, 2. So this time it's opening this way. Our p value is negative 2 because it's going in the negative direction. Y is squared, so this would be y minus 2 quantity squared equals 4p times x minus 3. H always goes with x, k always goes with y. And we just said that p is equal to negative 2, so y minus 2 quantity squared equals negative 8 times x minus 3 would be your equation. And then finally, a little word problem. You can see the vertex. The width of the archway is 8 meters down here, is what they're saying. Actually, no, that's not what they're saying. The width up here is 8 meters. How wide is the archway at ground level? So, okay, we have to figure out that this is going to be something 0 and something 0. So we have to come up with the equation. Since this is opening up or down, this is going to be x minus 0 quantity squared equals 4 times p times y minus 12. And then put a point in, because we don't know if for sure that this is the focal chord. So put a point in. So 4 minus 0